comparing understanding and memorization in physicalization and VR visualization. This work-in-progress paper is the result of Herent's master thesis at Bauhaus Universität Weimar. The young research area of data physicalization investigates the presentation of data in physical form, different from purely visual virtual form. How physicalization supports cognition, communication, learning, and problem solving is an active area of research. Some studies so far have looked at representations on screen in comparison to physicalization, but not at immersive virtual reality so far. Immersive visualization has the potential to support spatial understanding and memory due to its 3D nature and direct experience. It can provide a vivid, realistic imagery and sense of presence. What's naturally missing is the ability to touch. As a prior step to investigating the role of physical touch for understanding data representations and the effect of VR versus real world, we studied whether there's a difference to experiencing a representation in physical 3D or as a 3D visualization, that means VR, regarding the understanding and ability to recollect, that is memory. So this is an explorative study looking at how can we even start to compare the two. We chose a data set on meteorite landings. So this had 129 objects. We represented the data in terms of the year of the landing, the mass of the meteorite, and because we thought this would be the most interesting to our participants, how far did the meteorite come down away from them, so distance to our town, with the year along the x-axis and the distance on the y-axis. The height of each of these poles is the mass, and we put the little balls on top to make it easier to see. We designed this to work both in VR and in the physical world. The physical version was done in wood. The virtual representation uses a 3D model and a HMD setup to present the data, and it was all done in Blender. To match the material appearance, we photographed sections of the board and used these as a texture that got mapped onto the 3D model. And we used a HTC Vive Pro head-mounted display then. This was a between subjects study because we only had one model. It started with around 5 minutes of familiarization for the participants to explore the model, and they were given explanations of the axis. In phase 2, they were asked increasingly complex questions about the data set, and the time taken until a correct answer was given was recorded. If they got it wrong, they were told so and could try again. Then the model was removed, and the participant was distracted with questions about something else. Then followed another phase with memorization questions of increasing complexity, where we noted the correct answers. This finished with a short interview. In both conditions, participants were told they weren't allowed to touch the model. We had a convenient sample of participants, and as you can see, the physical version was done outside in a park. Our findings? The results indicate a considerably lower response times with the physicalization. So this is significantly faster. The light blue bars are visibly lower, and there's only one outlier question. Regarding short-term memorability, there's no evidence of differences between physicalization and virtualization. We also sketched the movement of people during the study, during the questioning phase and the familiarization. On the top, you see the 3 typical patterns for the physicalization, on the bottom for the VR condition. The majority of participants moved astonishingly little. We also noted that in the physicalization version, if people walked around the model, then only on the left. We ended up realizing that they evaded the researcher who was standing on the right. In VR, they simply couldn't see the researcher. Some participants, and that was across conditions, used the height of their body by kneeling down and crouching to adjust their eye line. And many tended to point at the model, and that was both in the real world and in VR, mid-air, even though they couldn't actually see their own hands. The physicalization group reported being more confident when answering questions, and the VR group complained considerably about graphics lag. We also observed fairly slow head movements in VR. resulting our insights and recommendations for future studies. VR still often isn't smooth enough, and that was a big problem in our study because it slowed people down and made them feel less comfortable. So VR needs at least 90 Hertz for a study to make sense. In terms of comparative study, we recommend to build the physicalization always first, so it's actually buildable, but also at this point to consider how to do the VR model, especially to consider the number of polygons required in VR, because this affects graphics performance. In our case, having a pole and a sphere per landing, both round objects, resulted in big polygon numbers and with that affected performance. For a comparative study, physicalization and virtualization must be identical in the representation, appearance, and material properties. We found that wood worked quite well. It was easy to work with physically, and it was also easy as a put-on texture in VR. And because it's not a reflective material, that also works nicely in VR. The perceived size of representations should be as equal as possible. And we also recommend to consider the study environment, maybe even recreate the lab in VR, and to consider the presence of observers because these will impact how people move around. We also had the feeling that participants' prior experience with virtual reality might be a factor in how confident they are in interacting in VR. In total, we don't have an answer on what's better, but we hope that we can provide insights and recommendations for further studies that look at this in more detail.